So in this lesson, what we're going to focus on is calculating the expected value of a random variable from our probability distribution. Okay. So before we can do that, we're going to have to talk a little bit about what we mean by the expected value. So the expected value, usually denoted by E of x, is the predicted average of all of the possible outcomes of the experiment. So if you did this experiment over and over and over again, took all of your results and averaged them together, what would you get as that average? Okay, what is the likely outcome, most likely outcome over time? So when we do expected value, we take into account how likely each outcome is to occur. Basically the probability of each event occurring. So it is, as I said, it is the average value that would be expected after many repetitions. Here is the formula for the expected value of a discrete random variable, okay, capital letter X. So again, we've got this big Greek letter S here, which means we are adding a bunch of things together, okay? All of the things that we are adding together, we are indicated by this subscript I. So what we have is these individual values, X subscript I. Those are the values of our discrete random variable. Okay. And over here, we've got the probability that our random variable is going to take on each one of those values. So we'll say the probability of each value. Or I shouldn't say of each value, of the particular value. Probability of the value. So if we were to expand this out a little bit, we would say that our expected value of our variable is our first outcome multiplied by the probability that that first outcome is going to occur, or the probability that our random variable will take on that value x1, plus, again, the value of our next outcome times the probability that it's going to take on that second outcome, plus, and so on, all the way up to however many possible values our random variable can take on. So basically what we are doing here is we are taking the total of each outcome multiplied by its likelihood, or how the probability that it's going to occur. Sorry, likelihood. So take each outcome, multiply by its likelihood or its probability, and add them all up. Okay? So let's look at an example. Okay. A coin is flipped 4 times. Determine the expected number of heads. So what they're asking here is if you were to do this experiment over and over and over and over again, on average, how many heads would you expect to turn up? We've got our table here showing our probability distribution. We put this together in the last lesson. So let's go ahead and calculate our expected value. So our expected value, we are going to use the formula from the last page for expected value. Okay. Sum over all of the values multiplied by the probability of these values. So what is our first value for the number of heads? Well, our first value here is 0. So we're going to have 0 times, how likely is that to occur? 1 over 16. Plus our next value, 1, times how likely is that to occur? Its probability is 4 over 16. Plus our next value, 2, times its probability, 6 over 16. Plus So next value 3 times its probability, which is 4 over 16. And finally, our last possible value is 4 with a probability of 1 over 16. Now we want to do this multiplication and then add everything up here. So this first term is just going to go away because I'm multiplying by 0. I'm going to get 4 over 16 plus 12 over 16 plus 12 over 16 plus 4 over 16. And if I add all of these up, I get 4 plus 12 is 16, 26, 28, 32 over 16, or 2. Therefore, if we were to do this experiment over and over and over, on average, we would expect heads to turn up twice. We would expect 2 heads to turn up. Now, in this case, our expected value was one of our possible outcomes. Okay? We could get 2 heads actually turning up. It doesn't always have to be that way. Let's put a little note down in here. The value E of x, expected value of x, does not have to be, and I'll underline not, a possible outcome. Okay. So a good example of this might be, let's say our experiment is rolling a die. What is our expected value for what is going to turn up? Well, the possible values are 1, 2, 3, 4, 5, and 6. Each one of these things has the same probability, 1 over 6. So our expected value is going to be 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. We can factor out the 1/6, okay? And then we can add up the 1, the 2, the 3, the 4, the 5, and the 6. And we get 1/6 times 21, or 3.5. So if we were to repeat this experiment over and over and over again, we would expect, on average, to get 3.5 as the number that's showing up. But on any one individual experiment, we can't get 3.5 showing up because the only possible outcomes are 1, 2, 3, 4, 5, and 6. So again, the expected value can be one of your possible outcomes, but it doesn't have to be.